Hello everyone, welcome to Achievers Tutorials. Today we are going to do digital electronics, electronic system in IGCSE 10th standard and in other this boards we have electronic systems and devices. What is an electronic system? We have moved from electrical to electronics using semiconductors. What are semiconductors? Those devices which are between insulators and conductors. If you remember the Ohm's law, V was proportional to I. This was the case in pure electrical system, pure conductors. Correct? So this is conductor. But when you talk about a semiconductor, the graph will be like this. Initially they are insulators. If we see the VI characteristic, they are insulators initially, right? But as soon as you provide a small voltage, they become conducting in nature. And in reverse bias condition, they are non-conducting, and this is a breakdown voltage basically. So this is your semiconductor. If we talk about electronic system is based from semiconductor. These semiconductors or germanium or gallium or silicon is used for making electronic devices. What is the basic principle of electronic device? You have an input, आपने कुछ भी input दिया, right? Or this will be processed. Processor will process. The transducer will convert into a different channel, wave, medium, and it will be transmitted. For example, if I am calling through a mobile phone is an electronic device. When I call, I speak sound waves, analog signal, and these analog signal will be smartly transferred into digital signals. How? Through a transducer. What is a transducer? A device which converts one form of energy into the other form. Usually analog energy into the digital form. They vibrate. So if you know that there is a magnet over here which will vibrate accordingly. The frequencies will be converted into digital forms. What is digital? Your AC and DC. AC means analog. At every point it is changing, and DC means only two levels. What are those two levels? Digital logic 1 and 0. Your computer language, your machine language. What is 1? What is 0? The 1 means high logic. Chalu hai circuit. Batti on hai. Lamp is on. 0 means the lamp is off. This is regular logic, but you can change the logic, pre-changed logic. You can always set 1 as switched off, 0 as on. So there are only 1 and 0s. So two basic logic works. This is your gate system, which will be seen in some time. So input, processor and transducers. This is your basic electronic device. What are transducers? I told you it converts one form of energy into another. The first transducer example I can give you is LDR, light dependent resistor. What is LDR? LDR is light dependent resistor. That means if at all you want to change the resistance, how would you change? There is a diode, right? This is the symbol of a diode. You should know PN junction diode. This is positive, this is negative. If this is connected to a P terminal, positive terminal, and if it is connected to a negative terminal, this will conduct basically. Now what is LDR? As soon as you supply light energy, when light falls on this particular device, the resistance will decrease. If the resistance decreases in the device, the current increases. So for example, if I want this lamp to glow, right, and there is a circuit here, for example, negative is connected to this, it will not work out because P has to be connected to a positive terminal. I connect positive, but still the lamp is not glowing unless light falls on this window. As soon as the light falls on this window, the resistance decreases. If the resistance decreases, the current increases and the lamp glows. You can use these LDRs in burglar alarm circuits also. This light energy can be a laser, can be infra or ultrasonic wave which is not visible. And what will happen? Infrared waves which is not visible. And if the burglar enters the circuit breaks and whatever your alarm will ring. Correct? So this is basic principle of LDR. One of the example of transducer, the light energy is changed into electrical energy. Can you see? Using this circuit. So one form of energy is basically changed into other form of energy. The second thing is thermistor. What is a thermistor? Thermal resistor is called thermistor. Therm means heat, resistor. What is a thermistor? We have done it in other chapter also. When the heat energy of this device increases when you pass the current or when you are heating a certain room. So when the heat energy increases, the resistance of this device will again fall. Here it was falling due to the intensity of light. Here it is falling because of the heat energy. So what is happening basically? As soon as the thermistor goes on heating, the heating effect increases, the resistance through this device decreases. And then you can use in the potential divider network, LDR also, thermistor also, and then you can use any application based on it. So this is basic thermistor. Any problem in the thermistor part? So thermistor symbol you should know. You have this kind of a symbol in thermistor. Thermistor symbol you should know, right? So thermal resistor, again what have you changed? You have changed the heat energy into the electrical energy. So heat is analog form of energy. Your light is analog form of energy. You are changing into pulses, electrical or electronic pulses, digital. That's called digitization, basically. If you think of an output transducer, you can always think of a relay. What is a relay again? It changes or it transmits the energy from one circuit to another. LEDs, we all are aware of LEDs. What is LED? LED means light emitting diode. Gallium arsenide is used here. Gallium arsenide. What happens on light emitting diode? What does it do? Everybody knows LED. In your houses today we are using more of LEDs. From small LEDs to the big ones. They use a very small voltage. Light emitting diode. This time they are emitting light. Based on the wavelength of the frequency, you can get red light, blue light, green light. You have with your colors, right? So these frequencies will be emitted as soon as you pass electric current through it. So can you see the basic difference between the symbol? Here light will fall and change the resistance. Here, as soon as the current is passed through the circuit, light will be emitted. Maybe a red, that wavelength, maybe a blue wavelength, maybe a green wavelength, and you can see the color, the light energy coming out. Basically, it's made from gallium arsenide. LEDs we use everywhere, right? If you go to the railway station, you have LED indicators. LEDs in your houses for lamps. Nowadays you don't use tube lights also. The tube light is also LED made. There are LEDs which will glow. Initially we had photons, electrons which were fused there. So 7-segment display you have seen in the indicators. If you see, you have 1, 2, 3, 4, 5, 6, 7. 7 LEDs are here. This is called 7-segment LED display. And if you want 0, what you will do? You will light this and this. You will not light this one. You get a 0. You can get 1. How will you get 1? You light only the right hand side LEDs. Same way 8. All the letters of your number system 0 to 9 you can formulate in this 7-segment LED display. So these are LEDs. Then you have semiconductor diodes. What is a diode? I have already told you. These are all diodes. What is a diode? I will give you for extended people what is a diode. This is basically the symbol of a diode. Diode, two electrodes, one here and one here. This is called positive terminal, this is called negative terminal. PN junction diode. You fuse the semiconductor device, and to make it work, you have to connect this to a positive and connect this to a negative. This is called forward biased, and the diode will work. The diode can act as a switch also. If it is in this mode, it will work, otherwise it will not work. This is called diode. You can have triode also, which is called a transistor, which is not there in our problem circuit, in our subject. So this is a diode. Please remember, this is called forward biased and it conducts. You will have MCQs also. If at all the same diode is connected in this manner, please see. I don't change the battery, I change the position. This is positive and this is negative. Negative is connected to the P part, so it will not conduct. This is called reverse biased. For extended people, this comes a reverse biased condition. You can have rectifiers, you have immense application on diode. For extended people, please remember the applications also. I'll give you the input and output through a single diode. Please see. If suppose you have a circuit where you use a diode, and here you have an AC input device. What is that? AC. AC means, you remember AC? Let's see, what is the input waveform of AC? This is the input waveform of AC. Can you see? Can you see? Okay, this is the input waveform of AC. So when this is positive, this is negative. Let's see the output. When this is positive, this will conduct PN conduct. So you get an output here. But when this is negative, minus and plus, it will not conduct. When this is not conducting, your device will not show any output. So this kind of output you will see. This is input waveform, this is output waveform. Can you see? You have input, you have output here, positive, positive. As soon as you give negative input, there is no output. This is called rectifier, half wave rectifier. Half of the wave is rectified. And then you can convert it to DC. You have full wave rectifiers also, where both the waves will be rectified, conducted. Correct? So let's go ahead, and digital electronics part also, gates, circuit waves should see. Okay, what are gates? As I told you, transistor is not there in your syllabus. When you go to higher standards, you will be seeing transistors. What are these chips? These are integrated through VVLSI technique. There are so many capacitors, transistors, inductors, resistors in a single chip. Right? So now what is a gate? Gate means either it is open or it is closed. So if you talk about an input, this is your AC input. What is DC? You should get either 1 or 0. So I change this a little bit in this manner, so that you get only 1 minus 1, or I term this as 1 and term this as 0. So you get 1 and 0 as logic 1, logic 0. So only two inputs are there. What type of gates you come across? We have formulated certain gates. The first gate is called the NOT gate, and the symbol is a triangle and a bubble here. This is called as a NOT gate. NOT means negation, negative, ulta. So if you have input as 1 here, your output will be 0. If you have input 0 here, output will be 1. That means if you connect an LED through a NOT gate, when you switch on the LED, it will be switched off actually. When you switch off the LED, it will be switched on actually. Ulta, opposite. This is called NOT gate. The second gate we come across is AND. And you should have two inputs for AND. So now I have two inputs here. This is a symbol of AND gate. Input 1, input 2. I say A and B input and Y is my output. Right? So what is A and B? So I have A here, B here, and A and B. A and B means Y is equal to A dot B basically. This is called AND. So if 1, 1, 0, 0, 1, 0, 1, 0. So when both the inputs are 1 in an AND gate, your output is 1. Otherwise your output is 0. This is your switching table or gate table which you should know. So that when you apply it in your application, you will get an output. For example, you can see the applications in your papers. You have an input coming from here, output coming from here. This is AND gate. Suppose this is your light. Switched off means 0. And here it is always on. Matlab 1. So what is the output of this AND gate? 0 and 1 will give you 0. Switched off. As soon as the light is on, your answer will be on. 1 gives you 1. That means your logic will tell us, if suppose I put this gate, light wala gate on your door. If your door is closed, that means you give that as 0. Input as 0. If your door is closed, input is 0, the light will be off. When your door is open, that means there is 1 here, 1 here. This is always 1. So there will be a light on. Like operation theater ka. You will understand inside also. The door is open out. Please go and close the door. Right? So these are certain applications. Then you have an OR gate. So what is OR? Basically addition. OR means addition. So for OR, you have this kind of a gate. Similar to AND, but AND is little parabolic in nature and this is triangular somewhat. Not triangular actually. So again you have input A, B, and there is an output which is called A plus B for OR. Again A, B is your input, A plus B is your output, 1, 1, 0, 0, 1, 0, 1, 0. In your OR gate, if both the inputs are 0, your output is 0. If both the inputs are 0, your output is 0. And here, for all other inputs, the output is 1. So again you can apply, right? 2 more gates we will be studying. Those are called XOR and basically NOR and NAND. They are universal gates. You can get all sort of gates from these 2 gates. Hence they are to be studied. So the first name is NAND and the other is NOR. What is NAND? AND gate को आपने NOT gate लगाया. This is called NAND. What is the symbol of NAND gate? You have a bubble in the AND gate. That is called NAND gate. So what is the output? A, B, A. This is NAND gate. Correct? Or you have A dot B bar. Bar means negative of this. So again 1, 1, 0, 0, 1, 0, 1, 0. What is the output of an AND gate? Opposite to that of an AND gate. If you remember, for AND gate, when both the inputs were 1, your answer was 1. Here it is ulta. 0, 1, 1, 1. How can you make a AND gate outfit? Just put a NOT gate, you get AND gate. Similarly, I have NOR. What is NOR? What is NOR? You put a NOT gate in front of a OR gate. That becomes a NOR. And what is the symbol for NOR? You have a bubble. Here the OR gate. So what is the input again? A, B, A plus B bar. Again 1, 1, 0, 0, 1, 0, 1, 0. What was the output of the OR gate? When both the inputs were 0, your output was 0. correct? And for NOR it will be ulta. When both the inputs are 0, your output is 1, rest all are 0. How can you get OR gate out of it? Just put a NOT gate in front of an or NOR gate. You get an OR gate. You get ulta outputs of it. These are called which gates? These are called universal gates. Logic gate control system. So these are some of the applications you should come across. And some applications are given in the textbook also, if you see properly, for street lights, for other operators, which we will solve. These kind of problems we will solve when we do the next class. So we stop here for today. If you have any problem, please get back to me. Thank you so much. Please like and comment. Thank you.